I'm Andy Mearns, and with our co-leader Chuck Drew, we're super excited about today. We've got Stephen Tibbitts with us, who is the founder and CVO of ZEVA Aero, and I'm super excited to be hearing from Steve today. A, because he's on our team, so we feel a certain pride about that. But also, he's been working on this longer than anyone I know, just about. I think it was 2005. He mentioned that he was working on eVTOL projects, has been submitting proposals to NASA since then, has done work with Joby, some really cool stuff. And he's been working on the ZEVA Zero with his organization, which is just an awesome, super exciting, very cool and unique design, sort of a flying pancake. And there's some really cool tech going into it. They've just had first flight, which is thrilling. And so we asked Steve if he could just chat about it a little bit today and tell us about the story that has been a very long one, but a successful one now. And thankfully he said yes. So we've got a little video that we may or may not be able to work. No fault of Steve's. We're just working on tech issues on our end. But if it works, great. It's a couple minutes long. If not, it's going to be a great story anyway. And then after we hear Steve's story, we'll talk a little bit about some research I've been doing on Part 103 regulations with from the FAA and what that means to us. And then if we have time, we'll talk a little bit about some updates Chuck and I were working on with respect to the white paper outline. Chuck, what else? What did I miss?
You missed nothing. Perfectly.
All right. Steve, is this a good time for us to hear from you? If so, take it away, sir.
Sure. Can you guys hear me? Well, thanks, Andy and Chuck. This is an awesome opportunity. Yeah, you're right. It's been a long time coming, and finally making some reasonably good progress. So I'm going to start open with the video. If I could try to get my screen sharing going again. Come on, share tray. Where are you? Okay, there you go. So this is January 9th out at the farm. So I hope the video works out okay. But here we go.
And Steve, I don't know if I'm not hearing any sound. I'm not sure if it matters whether you're muted or not.
Is that any better?
I can hear the sound now.
little celebration at the end there. So I threw the video up in the chat just in case you guys wanted to review a higher fidelity version of it. That was an amazing day for us, because if you think about it, it was a January day in Washington State, and the sun came out, and it turned out to be a 50-degree day, and it's just, the stars lined up for us. It was amazing because it was such a perfect weather, perfect time, relatively calm winds, and yeah, it was great. So I really appreciate the opportunity to talk about our journey a little bit.
Steve, I can't see you right now. Is your screen shared?
I unshared the video so I could share the other one.
Great.
So I'm just working on that at this moment. Let's see here. I'm going to play in PowerPoint, not in present mode, just because if I put it in present mode, the resolution becomes too high, and I don't think it'll work for you guys. So how does that look? Is that working?
We can see it.
Okay. So ZEVA stands for Zero Emissions Electric Vertical Aircraft. And to open up with a tall claim, I like to pull analogies, and this analogy is that in 1989 Bill Gates said computer on every desk, and in 2019 we're saying ZEVA in every garage. So that's kind of our goal, personal air travel. But I want to jump in and talk a little bit about my background and how I came to this. Private pilot, serial entrepreneur. I've had 2 reasonably successful exits. Washington State University, bachelor's in electrical engineering. I spent most of my career in chip design, chip development, both in actual design of high-speed logic and memory and mixed signal. So I've done a lot of different things in super high tech. I consider myself a Silicon Valley engineer, but I've never actually lived in the Bay Area. So I've been fortunate to live in the Pacific Northwest most of my career. And why am I doing this? I really think that eVTOL vehicles represent the largest opportunity of our lifetimes, and so it's very exciting to me. But that's not really how things started. I had done a consulting job with Intel back in 2002 timeframe, and I made enough money that I decided I'm going to take 3 months off and get my pilot's license. So I did, and ended up buying this little 172 5.7 X-ray factory seaplane. And my dream was to throw a folding mountain bike in the back seat and fly into the local airport and then ride the last mile. What I ended up finding out is that a lot of the little airports that I knew about growing up were gone. So my dream was sort of shattered because we could no longer fly close enough to a bike ride to where your destination is. And the reason behind it is that, the land becomes too valuable, and the FBO is not making enough money, not selling enough gas. The airport they decide to sell it, and in go the condos, and away goes the airport. So I knew at least on the 2 coasts of the United States, this was a theme and a problem for general aviation. So I started noodling on it, and I thought about, well, what about flying cars? And turns out that I'm not the first one to think about this. Glenn Curtis, who's one of my idols, if you will, in aviation, thought about this in 1917. So that was thinking about it further. I mean, everybody loves the idea of flying cars because it's like a single vehicle. You can fly it and drive it. The problem is they still require a runway. So that the runway is the gating item in my mind. So ultimately, I decided that it had to be vertical takeoff and landing. And since I'm an electrical engineer, I decided it should be electric. So I actually wrote a grant proposal to NASA in 2005 which is available on our website if you're interested in that. But anyway, I view this as being one of the earlier prognostications of electric vertical flight. And I actually shared this paper with Joe Ben Beavert from Joby back in probably 2006 or 7. And I think that, I had an influence in the whole entire industry, what's happening today. But I didn't get the grant. I got 2 thumbs up and 1 thumb down. So I didn't win any grant money, and I had to put food on the table. So I just continued on with my day job. But in 2017, we learned about the GoFly Prize sponsored by Boeing. So we put a team together to go pursue this GoFly Prize. And ultimately, we ended up with the design. We wanted to maximize our wing area. So we ended up with this round wing to max. If you don't know too much about the GoFly Prize, the constraint is the entire vehicle has to fit within an 8.5-foot sphere. So we took that sphere and we tried to maximize our amount of lift in forward flight and figured out how to do basically a tail sitter with this unique design that transitions to forward flight like this. So it takes off vertically as on the far right, and then transitions to forward flight where we're generating lift. And the thought process is that it was very, very, very difficult to run the requirements of the GoFly Prize or have any reasonable duration and range if you're just hovering. But if you can transition and generate some lift, you can cut your power consumption down to about 40% of what the power consumption is for just static hover mode. So that's the concept behind it. And I think this chart here kind of shows it. So we basically kind of took the idea of having an octocopter and turned it 90 degrees, where when it's in forward flight, it's generating lift. And like I said, generating about 40% of the energy requirements. So I didn't actually know this at the time, but it turns out that the round wing wasn't really unique. There was some studies done all the way back to 1934 with the Parasol, and also the Vought V173, lovingly referred to as the Flying Flapjack, were aircraft that had round wings. And serendipity, it was that the round wing offers interesting aerodynamic properties. It has a very forgiving stall angle of attack. So in other words, you can fly the vehicle at a high angle of attack and still generate lift without stalling. And that helps with their transition phases. When the team was working on this, Uber Elevate 2 happened, and this was probably a very catalyzing event for the entire industry. And their mission or goal was to control traffic in and out of the city center to airport and things like that. So they dreamt up and hired architects to conceptualize what this might look like. And of course, at the time we were all, pre-COVID, we're all very much feeling trapped by the amount of traffic in any of the worldwide cities. And so it was a good goal. But what I think they really kind of missed the mark in terms of looking at the data. So if you look at the data, 76% of Americans drive alone to work. So there's a couple things going on. One is that we are all kind of mavericks and want to control our own destiny. And the second thing is the cost structure. If you look at the very data that was presented at Elevate, you'll see that they were looking at cost models and they're literally trying to generate large volumes of operations. In other words, they want to land and take off a particular vehicle up to 1,000 times a day, which it's just a daunting problem to tackle. And that was because they wanted to drive the cost down. Well, if you look at the very chart that they presented, single personal vehicle ownership all the way over to the right is actually the lowest lowest cost overall. And I think they just completely ignored this data. So that's just an anecdotal piece of information. The second thing is that I think for eVTOL vehicles, I don't know if it's a great idea for having the most populated urban environments to be the testing ground for them. So, we like to think of using these vehicles for areas that don't have infrastructure and never will. So, you look at island nations like Indonesia that have 17 or 18,000 islands, and as well as areas like the Amazon basin where, travel is extremely problematic, especially for emergency services. And even in my own backyard, the San Juan Islands are, if you need emergency services, you're talking about either a helicopter or a ferry ride. So one's a slow boat and the other is going to be very expensive. So this is kind of what our proposal is. Our solution is a single personal air vehicle, and we think it'll be useful for not only personal air travel but first responders, saving lives by getting the medic out on the scene as fast as possible, search and rescue, law enforcement, cargo, resupply, and ship to shore. We like to say that it turns every boat into an aircraft carrier. And so the two percenters that can't afford the 75-meter yacht that the one percenters have can now have their own personal air vehicle on their yacht. So our goal is ultimately consumer-owned point-to-point electric vertical takeoff and landing aircraft. We know that it's going to take time to get there, and it's a progression. We realize that in order to have it consumer-owned for people that aren't pilots, we have to have automation. And I like to think about the Zero as being a flying robot that's skilled at moving people and goods around. So the idea is that it would be, you'd get in the machine or summon it from your phone, basically, have it land near you, get in it, have a conversational AI that you can tell it where you want to go. Probably have to push a confirmation button on the screen, but the AI inside the vehicle will communicate with air traffic management and chart the course between point A and point B. So that's the long range goal, and we see that happening probably 2026 or 2027. This all of this stuff's being worked on, not necessarily by ZEVA, but we certainly have opinions on how it can work. But Boeing has invested, over $50 million in a company called SkyGrid with a joint venture, and NASA has agreements to work on this with the Air Force as well. So it's, things are happening. A lot of different companies are vying for these different technologies that will help make this happen. So as far as the timeline for ZEVA, this is kind of how we look at the evolution of eVTOL. I think, we'd all agree that in about 2020, maybe some delay due to COVID, eVTOL burst onto the world stage. We think that there will be some early air taxi services in 2025-ish. Rural air mobility and advanced air mobility will become ubiquitous in 2030. And then beyond that, I believe that personal ownership and consumer owned VTOL will become the norm. So what does this blended wing body give us? It basically gives us speed and range. So if you look at just comparisons with other single passenger machines, our velocity is pretty high because we're very aerodynamic and efficient. And then because we're fast, we have a longer range with a comparable duration. So that's really the differentiator are really threefold. One, speed, range, or one, speed, two, range, and then three, compact size. So the other thing that we have with respect to most other vehicles that we're smaller footprint. I'm super proud of what the team has done. Here's just a picture of things that we've done. This thing on the left is the mold for our belly pan. So we literally are, for a small team, we're vertically integrated. We did all of the composites in-house, and we have cut CNC wing molds for our wing structure as well. I didn't have a picture of that handy, but we've accomplished a lot, and I think the video, that's why the video was such a huge celebration for us, and we were humbled that we got to this point, you know, not in the time frame that we wanted to, but we finally pulled it off, and now the team is looking at the next big mountain, which is getting to transitional flight. So we're working on plans for that and setting up UAM or UAS test ranges to get. We're actually on the COA for which is a certificate of authorization for Pendleton, Oregon, as a test flight zone. It's just a matter of getting that scheduled and figuring out our exact plan. But you can imagine that it's daunting going from where we're at now to getting to transitional flight, and you know, a million little decisions to make along the way. So I know it's hard to be interactive with Zoom, but I'd be happy to answer any questions, or I wish it could be a little bit more interactive. But anyway, any questions at all?
Hey, Steve, this is Johnny.
Hey, John.
Impressive. I mean, congratulations again to you for the first flight. I know that's always emotional, but I do have a very serious question for you. Once you start flying, conduct a lot more flying with this thing, how are you going to control all the UFO reporting?
You know, that's funny. We get those UFO reports just driving down the road with the vehicle on the trailer.
I figure that, yeah.
Yeah. Yeah, I don't know. That's a good question. I mean, arguably there's DoD interest in it for kind of stealth operations. So, you know, it's a of course we could coat the carbon fiber in any kind of absorptive material, and then since there's almost no heat signature and can fly low and fast, there's significant interest there. But yeah, that's a good question. There will be UFO call-ins, I'm sure.
Yeah, that would be a good problem to have, wouldn't it? That means you're flying a lot.
Yeah, it's true.
Stephen, I have a question. That's
to your transition flight. That's it's great day for you guys, and yeah, it's for the industry. I mean, it's an unusual design. It creates by the design itself, I think, generate a lot of discussions that I know of. So yeah. Impressive, and congratulations again.
Thank you, Johnny.
Did somebody else have a question? I thought there was another one as well.
Yeah, Stephen, I have a quick question, if that's okay. So I'm wondering, so the spheroid, or the sphere maximum envelope reminds me a little bit of like the mid-90s NASA specification for micro air vehicles, where it has to fit in a certain volume. And so we at the time we were pushing on micro air vehicles, 6 and 7 inch, you know, flying vehicles. What we found, obviously, like a lot of other people, right, is that that's a really difficult constraining envelope for an aircraft, even if it sort of makes sense from a transportation storage standpoint. So my question is, you know, I realize the impetus for the design came from a spherical envelope. Does the design change at all when that constraining envelope is removed?
Oh yeah, definitely. Yeah, the design that we're flying right now probably won't be a production model. You know, the real there's some real problems with it, in you know, largely is just a functionality of the landing gear, for example. So we will violate that prescribed spherical shape that the GoFly prize dictated for our production model. So that's a good question. But yeah, we don't, you know, for the commercial application, we don't see a need to stay within that constraint any longer. But I still believe the round wing does have some unique shapes or unique characteristics.
Yeah, I guess especially for transition, right, where you don't have that distinct stall boundary anymore. But anyways, thank you for your answer.
Yeah, you're welcome.
Steve, this is Andy. I'd be curious to learn about what your thoughts are with respect to what applications will you know, will be best for you in terms of placing production models. I could see so much. I can see military, recreation. I mean, this is the aircraft we finally all wanted to feel like a superhero. There's a lot of ways to go with it. What are your thoughts?
Yeah, it's a tricky question because we're fundraising always like any startup company, and the financial guys want you to be very, very specific on your target market, and but it's really hard because there are so many different applications. I think that we've gotten requests from you know really wealthy people that just want to fly from their lake house to the city or whatever, so there's the guys that want them for their yachts, and there's also, we really think that there's life-saving potential for emergency services. So for flying medics, I think is the real, one of the early keys for us is getting these in the, I can imagine one of these parked at every firehouse with a medic that knows how to fly and get there out to treat the trauma immediately and save lots of lives. And I think, Johnny can address this too, but I see that as one of the early real benefits to the society for vehicles like this.
Well, if I may, I'm going to pull on that string a little bit. 30 years in the fire service, ran about 10,000 calls with walkie-talkies. It sure would be great if we had situational awareness and IoT and real-time Web 3.0, Industry 4.0, digital twins.
30 minutes. Thanks, Lee.
So thanks for taking some steps and getting us advanced air mobility stuff. May I ask the payload?
200 pounds right now.
Okay.
So,
and,
go ahead.
And a couple teams are working with some trials on putting what's termed putting fire on the ground. So control burns, either to assist in active wildfires or to clear. So dropping incendiary devices to get the fire started early in the season, which is now year round, or also suppression efforts. But absolutely EMS work, good stuff. I will ping you directly with an email. Love to get more information, and I'll spread it in my network. Thank you.
That's great, Kirk. Great to meet you, and thank you for the encouraging words. We do need, people that will stand up and say, yeah, we want to be a customer for this, right? We need people to say, ultimately, if ZEVA, if you do these 12 things, we'll buy 10 machines for trials or whatever like that. So we definitely need market pull and evidence of that for fundraising purposes, and just getting more feedback so we know what to build for you guys. That's really important. So thank you.
Hey, Kurt, this is Johnny too. If you don't mind, copy me on the email on this aspect as well, would you?
Yes, sir. Happy to. I'll put my email in the chat bar here, and if you don't mind, give me yours, and we'll get something going. The other thing I might do is pass you on to I'm an adjunct professor on the next gen and UAS course. The next gen is more my side of things, and my co-professor handles the UAS. He'd be the person to go there. Another go-to person. But yeah, I'll put my email in the chat. Thanks.
Great, thank you.
Excellent. I have another question, but I want to give somebody else a turn. Who else has one brewing?
I had a question. So, well, congratulations also. It's very exciting. So you had said that you were thinking that it was going to be pretty quickly adopted into like an AI interaction type of product. So do you think that that is the way that it will start, or do you think that you'll have a production line that is geared towards pilots first and people who are more comfortable or capable, or will they just go straight into something that's like user friendly?
No, I don't think we want to wait for the AI piece to come along. We definitely want to start making vehicles as soon as possible and get them into the hands of pilots, and offer training for that. I don't think that it's having a pilot's license. I don't think is that much of a burden, especially for people like EMS and medics that are willing to do that. I personally know a couple of flight nurses that would love to participate in something like this. So the short answer is no. We don't want to wait until the autonomy is ready. Probably the biggest, optimistically, I see the autonomy piece being easier in the air than it is on the ground. So there's a lot of companies that are working on automotive autonomy. I think that we have a slightly easier job doing it in the air. That being said, I think the bigger challenge for air autonomy is going to be FAA sign off. And that could take years. So we don't want to wait until that happens.
So a couple of Chuck here, a couple of items, Stephen. First of all, I think Andrew can address some of the pilot requirements, I suspect the lack of pilot requirements for your aircraft. I think you can do that, Andy. The second thing is you're definitely right that the autonomy in the air is far, far, far easier than it is for the ground. In fact, there's one aircraft flying now, TBM 940, which is a beautiful single-engine turboprop built by France, and there's a wonderful little button called "Go Home" at the top. So if somebody has a medical event, any passenger can push the button. This aircraft will fly to any specific airport that's closest, that's suitable, extend the gear, configure, land on the runway, and shut down. So autonomy is there. But you're right. FAA is going to take some time to buy off.
So
Yes.
we're at about halfway through our meeting, and I've got about a 20-minute presentation that I want to do, but I was hoping we would run as long as we could with your conversation, Steve, because this is fascinating and just kind of really cool work. Maybe we'll do another question or two before we move on, if there's another one or two questions out there.
Well, Andy, I'm also looking forward to your presentation, so I'm okay jumping in with that as well.
Actually, we could segue. Does anybody else have a question? Because otherwise, I've got a segue question for Steve. I'm going to talk about Part 103, FAA's Part 103 regulations today, and that is for ultralight aircraft. And so, just to segue into that, Steve, I thought I'd ask you for a minute or two on your thoughts about regulations and how the Zero will fit into the current FAA framework.
We are seeking experimental classification now, but that question of ultralight comes up all the time, and it's something we're constantly looking at. And it's very puzzling to me because I think we can get there with limited range and limited capability, but we'd also pretty much have to be amphibious. So if you look at guys like Lyft, one of our admirable people in a similar area of the industry, they are quoting on their website, they quote a very large, much higher than the Part 103 specification of weight. The way I calculate it, I don't see, let's scroll back and find that number. It's, if we're amphibious, they give you, I think, 30 pounds per float. So if you're generous and say there's 4 floats, that's an extra 120 pounds. But the bottom line is that you end up with something, south of 400 pounds empty weight for an ultralight. And I don't know if Lyft aircraft has a variance but they're quoting something like about 450 pounds. So I don't know how they're doing that. If we could do the same thing and get a variance, then I think it may be interesting. It may be an interesting vehicle to provide as an ultralight. So that's definitely something that we're constantly looking at. But it's super challenging. I mean, if you're not really familiar with it, you'll know that electric vehicles are handicapped by the fact that the FAA allows them to have an empty weight, and they don't count the weight of the gasoline, right? So you get five gallons of gas on top of the empty weight. Well, in batteries, you have your full energy system is takes up weight, whether there's no way to empty the batteries, basically.
That's right.
So I don't know if the FAA or we, maybe we can lobby them to say, hey, this is an unfair disadvantage for electric, but it's a real thing. So, early on, guys like Kitty Hawk figured this out, and that's why the Kitty Hawk and the Black Fly, they were all amphibious, because that gave them additional gross weight capability. But yeah, good question. Something we're always looking at. I don't know, if there's a tremendous amount of market pull for it, we would definitely work harder and try to figure out how to make it happen.
Excellent, excellent. Okay, well, if this is a good time, I'm going to say thank you very much, Steve. That was fantastic and super informative, and your work is just amazing that you and your team have been doing. So you should. I know you got to be proud of yourselves. It's just amazing to see. Congratulations.
Well, thank you. I feel blessed, and I'm super proud of the team. So I appreciate the ability to share. Thanks.
Yeah, definitely. Okay. I'm trying to, let's see. Can you guys see my presentation yet?
Yes, I can, Andrew.
Okay, great. And did the slide just change? I'm praying.
It did, Andrew.
Outstanding. Okay, good news, good news. All right, so my background in the aviation world is in selling corporate jets that are flown privately by corporations or by charter companies. So those regulations are, under FAA Part 91 and 135, which is sort of what I'm used to, and it really offers a cocoon of safety. If you operate within those regulations, you're afforded all sorts of safety protections in terms of limitations about what the aircraft can and can't do, the certifications on the aircraft, the knowledge and the training that the crews in the business have to undergo. It all offers a big cocoon of safety. And so in learning about Part 103, which is ultralight aircraft operations, I learned what there's some similarities and differences. And the differences really come about from the roots and history of where Part 103 came from. And it's been around for a while. It was written in it's from the early 80s, and it's about 40 years old. And if you look back in history, the sort of 70s and 80s were really when hang gliders were really starting to take off. And so Part 103 operations in one way is an answer to, the question, okay, FAA, there's all these, little aircraft running around. What are you going to do about it? And what aren't you going to do about it? Or, is everybody going to have a radio on their hang glider and go to flight school? Or, how is this all going to work? And so that's what these regulations were intended to answer, to give us some guidance on how it'll all work. So what Part 103 says is, if your aircraft fits a specific set of criteria in terms of its size, the performance of the vehicle, its configuration, and the way that it's operated, if that vehicle fits into these criteria, then there's a window. There's a bubble that you can work within. And you've got some latitude and freedoms there, where if you're operating this aircraft, this type of vehicle, they call it, then you don't have to have the vehicle certified like a corporate jet or a commercial airliner would. The operator doesn't have to get a pilot's license. So if you're flying a hang glider or something like that, you don't have to go and go to flight school, and you don't have age or medical requirements. The FAA with Part 103 does provide some operational rules and requirements. So it sort of gives us a window within which we can operate with these specific types of aircraft. So I've got two slides here about what vehicles fit into this category. What's the vehicle applicability? And there's a couple specific things that the FAA is looking for. They want a manned aircraft as opposed to a drone. It's a single occupant vehicle, and its purpose is just for fun. It's not for business. It doesn't have a task. It's not a money-making operation. It's just like a hang glider or this guy in the balloon flying around for fun. If it's an unpowered vehicle like the one we're looking at, it weighs less than 155 pounds. If it's a powered vehicle, then there are some additional requirements. It needs to weigh less than 254 pounds, and its speed is limited to 55 knots. As Steve alluded to, it can carry up to, but not over 5 gallons of fuel, and it's got a power off speed that's less than 24 knots. So that's what kind of vehicle applies here. If the vehicle fits into that category, then there's lots of latitude in terms of certification and registration. The vehicle does not have to go through a certification process. The operator doesn't have to get a license. They don't have to fit experience, age, or medical or knowledge profile. And the vehicle doesn't have to get registered. It doesn't have to have a tail number or be registered with the FAA. There's some operating rules that go along with these regulations, and it says that essentially you can't run your hang glider at night. You need to be operating at day, and you can't be over assemblies of people, so you can't be operating over a stadium, for example, or over a city, that sort of thing. And it's okay. It can be possible to go within restricted airspaces, but there has to be ATC approval at minimum, and there are also other requirements as well. But at minimum, there would have to be ATC approval to go into airport environments. Visual reference with the surface is required, and the aircraft has to stay. The vehicle has to stay clear of clouds. There are minimums within the regulations that specify how far away from clouds you have to be. So that's kind of the summary of the regulations that came out in 1982. And then in 1984, the FAA published an advisory circular to answer some of the questions that clearly had come up, and also provide some additional guidance above and beyond what was initially included in the just the bare bones regulations themselves. And so that advisory circular is here, and it's just really exists to lay the sticks out straight, and also add some new nuances, such as what Steve mentioned, which is how does the weight work if you've got some safety equipment on board, like a parachute and like a floats and things like that. So this is just a little bit about the advisory circular, and what it's doing is kind of giving us some specificity about what are the differences between ultralight vehicles and certified aircraft. And it's important to note, and that's why I've highlighted them as I have, that the FAA considers them two completely different things. You've got an operator is who's flying an ultralight aircraft, as opposed to a pilot that is flying a certified aircraft. And the FAA looks at those two things differently. So we talked about, Steve mentioned the weight issue, and this advisory circular is where we find information that says, right, if you've got some safety equipment, like a parachute, you get some weight credit for that. So you don't have to count up to 24 pounds, or at least 24 pounds of the weight of a parachute system against your weight minimums, which is great. Similarly with floats, in this advisory circular is where it specifies if you've got a float or a couple floats, you can discount up to 30 pounds per float from your weight totals, which is helpful. And then it also specifies for other onboard devices that could be construed as safety oriented, like seat belts and roll cages. It just specifies no, those are going to have to be included in your weight. So it just gives us a little bit of guidance there. And then further clarification about the issue of recreation and sport purposes only. Really, what it's saying is that if your vehicle has a job, then it doesn't fit into this category if you're using it to make money. And this was an interesting sentence that I saw in the circular. The reason for allowing operations of these vehicles without requiring aircraft and pilot certification is that the activity is a sport generally conducted away from concentrations of population and aircraft operations. So what they're saying is we're giving you some latitude here because we're hoping that you're not going to be over a city. You're going to be off on your own, and that's going to help keep other people safe. And along the same vein, this section's saying that if the flight has a specific task or a job, then it doesn't fit under Part 103. However, there's an exception, which is public service. So they have a little section about public aircraft, and that's an aircraft exclusively used in the service of the federal, state, or local government, and that might be like the fire or fire example we used before, or police. Could be local or state police, things like that. Then in that case, the aircraft can have a job, and it still won't require an airworthiness certificate, and the pilots don't have to go get a pilot's license. So the FAA essentially is saying to other federal entities, look, we're a federal entity at the FAA. You are too. If you want to operate this aircraft, that's on you. We're not above you in that respect. So you need to take care of your own safety issues. But if you want to operate in the national airspace, please just do adhere by our rules so that we're all on the same page. And along those lines, the FAA is also saying in that case, then the public service aircraft has to be registered with the FAA, have a tail number, and operate within Part 91 regulations. But this is a big deal because it could be a big time and money saver for fire departments, for state police, entities like that, because as a non-certified aircraft, it's just much less expensive to develop and produce. And since the operators don't have to have pilot's licenses, it can be less expensive and simpler for them to get up in the air and saving lives and saving forests and things like that.
Hey, Andrew.
Yeah.
Stephen raised his hand. I think Steve may have a question.
Steve, did you have a question? Thank you.
Yeah, circling back to the float concept, I'm wondering, I haven't found it. Is there any kind of discussion of the number of floats that you can utilize with the weight budget?
I would check into the this circular. My understanding from reading it is that it was not limited to a float. In other words, if you had a left float and a right float, then you could get 30 pounds of credit for each of those two floats, 60 pounds total. I did not see anything along the lines of a limitation as to how many floats total. There's also a note in there that says that if your hull, if you have an amphibious hull, then that also will get another 30 pounds of credit. So if you had sort of like, a hull and then, and there's actually a note about outriggers too. Give this circular a read. It's, if you're an aviation nerd like me, it's fascinating or at least interesting. And you'll find some cool stuff in there along those lines.
Okay, thank you.
Yep. So I just got this slide and one slide left, and just to kind of tie things off, I wanted to just give you a quick snapshot of what I feel like I learned. And the way that these regulations work are different than other regulations that I've seen, in that what they seem to be intending to do is to carve out a space for operators to work within inside this envelope to essentially keep others safe. And the circular goes so far as to even say that. It says the rules in Part 103 are intended to assure the safety of those not involved in the sport, including persons and property on the surface and other users of the airspace. So they're trying to make a place for hang gliders and other light vehicles to operate, so that they can have the freedom to do so, but in a way that they're not going to hurt other people and potentially if there's unsafe operations. And no doubt that's a big reason why there's the single pilot, the single operator restriction, so that you don't have somebody with an aircraft that hasn't been inspected, that maybe isn't safe, that's taking up friends and family every weekend and potentially putting other people in harm's way. Further, it goes on to say that Part 103 is based on the assumption that any individual who elects to fly an ultralight vehicle has assessed the dangers involved and assumes personal responsibility for his or her safety. So again, we're saying here that, you know, that they're the person who's at risk, but because there's a single pilot, single operator restriction, they're not going to be able to put anybody else at risk. And in keeping these vehicles away from, you know, masses of people over cities and sort of things, the idea is to keep them safe as well. And so there's broad freedoms that are provided here, but there are critical responsibilities that that stay with the operator and also with the manufacturers and builders of these aircraft. And really what encompasses both of those is what they call the ultralight community. So what the FAA is saying here is, look, we're giving you some broad license to do what you want to do and just have fun with it, but this is on you to keep things safe. We're not going to impose these regulations unless we have to. And you know, you see these lines, they're not pulling any punches. They're saying, please don't make us. If you force our hand, we're going to have to make regulations. We have other things to do. And the safety record of ultralight vehicles will be the determinant of whether we have to step in and crack down, or if we can continue to operate this window of operation for you without getting involved. So this is an important thing that I learned, is that really what they're saying is, it's on you. You've got to do everything you need to do as an industry to keep safe. And what I would take from that is that if anybody's in the industry, it is kind of in their best interest to look out for what's happening with all the operators in the ultralight community. In other words, if there's another operator with an aircraft that is going to be operating under Part 103 regulations that's less safe, that is going to cause problems, it is in the best interest of everybody else in this community to step in and say, hey, don't do that. You've got to be safe, because once one entity gets us into trouble, we're kind of all in that boat, and we're all going to have to live with potential new regulations. So the last slide I'll leave you with is, these are links on where you can find the regulations themselves that I've tried to summarize here, and also the advisory circular that gives us more clarity. And then finally, at the end of this month, the Experimental Aircraft Association is having their virtual ultralight days. They've got 3 days of online conferences that you can jump in on, and some of them are educational about Part 103. Some of them are educational about the vehicles that they're operating, how they operate within the airspace, things like that. So and I signed up for a couple of them myself. I think there's a lot of knowledge to be picked up from them, and it's just a great organization to jump in with. And that's the end of our presentation. Are there any questions?
Yeah, great presentation, Andy. I was wondering if you could grab that last slide, the links, and throw them in the chat so we can cut and paste them.
Happy to do it. And also, that entire presentation is within the group folder. So if you want to snag it, have at it. It's got the links there as well. And I will also grab the last page and put it in the notes. But if you want your own copy of that presentation, it's there waiting for you.
Excellent. Thank you.
Yeah, sure. Any other questions?
And hey, this Johnny Do.
Yeah.
It's great summary. I think that really helped clarify quite a bit of the possibilities. I think there's quite a few discussions and possibilities of single seat eVTOL, trying our best to fit in the 103 intended guidelines and so on. So it's going to be interesting to see how this direction goes, and whether additional dialogue or FA side may step in and clarify a few things or not. I guess will be interesting, but great material. Thank you.
Yeah.
Do have a request. I think once you start talking, you have to take the audience request, right? Like a performer, the musical performance.
Sure.
So it would be interesting if you could have a look at. I haven't heard as much talk about the light sports category, whether that have any possibility. I understand there's some language in there that may limit its use on applicability for eVTOL. But yeah, when you at your spare time, that would be that would be an interesting subject to dive into as well.
Well,
Definitely.
and it's Chuck here. I'll take a look too, because the LSA category, I think, is going to open up a lot.
That would be good. I heard that it's being worked on or looked at right now to provide much better possibilities there for eVTOL related design of vehicles. So yeah, that would be great.
Yeah, Johnny, I think that's probably where some of this stuff is going to go. I mean, the LSA category is pretty significant in terms of weight. I mean, I think it's up 1,500 pounds or 14 or something. What is it? Do you know, Andrew?
I don't.
Okay.
Yeah, that definitely the weight category. It's a lot of light sports are two-seater, so at least you got that range.
Yeah, I think the Cessna 150 will fit into the LSA category.
Okay, that would be neat. Yeah.
So we only have about 2 minutes left, unfortunately. But Johnny, I want to tell you, I'm not done with this topic. I do intend to keep running it down. I found some other interesting rabbit holes that when I have some more time, I want to dig into and present on. And the other thing too is that you hit on something about potential FAA regulations going forward. There's two ways to do this. Is if we do nothing, then accidents happen with even the safest type of aviation, and when they do, that forces the hand of the FAA because it involves the public and it involves safety, which the FAA is obviously concerned about. So a better way is for us to start kind of circling the wagons together and saying, okay, we need to regulate ourselves and talk about what makes the most sense internally, and then build out that knowledge set and interface directly with the FAA based on a working group of organizations that are working within this space.
So Andrew, that's actually called tombstone legislation for the FAA.
Okay.
They do legislation when there's enough tombstones. So
yeah.
But and I think I'm 100% agree with you. I think the best approach is the industry work together. We compete. A company can compete on product or market, but a company will never compete on safety. And to have a safe industry is beneficial for everybody.
Yes.
As you say earlier. So it would, I 100% agree with you. I think the best approach, which our working groups can play a role in this, and getting the players together to regulate them ourselves.
That's right.
To provide a high safety record for all participants. That way, FAA will not be, as you said, forcing to apply additional regulatory, sometimes overreaching limitations, and so on.
Yeah.
And if we think there may be requirement need to clarify one or two statements in there, I think it would be best that the industry provide a consensus language, and rather than just ask FAA to give us, well, you don't know what's going to come up.
I'm going to keep moving forward with that. I agree 100%, and I saw it clear as day, and you do too. I can tell that there's a great opportunity here for us to circle up, collaborate, and make life a lot easier for everybody, ourselves first and foremost, but the FAA as well. So that'll be a next step. Everyone, we're at a little after 3 o'clock. Just a super successful meeting. Thank you very much to Steve Tibbitts. Wonderful, fascinating presentation that I know we all really enjoyed. So thank you very much, Steve.
Thanks, everyone.
And thanks everyone.
Steve.
Today. We'll see you next month.
Thank you, Steve.
Good discussion.
Yeah, I want to get a ride soon.
I'm Come on out. Let's do
Thank
it.
you. Thank you.